search or sort function for the user to manage the data. Add comment. The user will be able to add comment to a specific drafting event. The last one is delete draft events. So the race director sometimes will want to delete a drafting violation if it's not valid. So we provide this function. Here's the main GUI for our software. As you can see, the main part of the GUI is a table displaying detailed information about the drafting events, including the drafter ID, last name, first name, and so on. And to the right of the table, there are several buttons correspond to the functions that I just talked about, and except for sorting. If the user wants to sort, they can just click on the header of each column of the table, so the drafting events will be sorted accordingly. Here's the cost of our project. We purchased enclosure, power supply, battery charger, and microprocessor, as well as 4 pairs of sensors. We also spent some money on general assembly and shipping, so it comes out that the total cost is $945. Future improvement. We suggest that the future team to improve the integration between wireless and distance sensing module, because they interrupt with each other. We're using a switch to switch between the wireless code and drafting mode. Another improvement is to use a Hall effect sensor instead of a switch to switch between them, so the user don't have to manually flipping the switch. Another improvement is to implement the 2-meter width of the drafting detection. As Shawn mentioned before, the drafting zone is actually a 7 meter by 2 meters rectangle, so we are only required to implement the 7 meter part. So the future team can also implement the 2 meter part as well. Is there any questions?
Thank you. Questions?
Probably I have a silly question. What prevents you to implement some kind of warning signal like beep for the person who is about to violate the rule?
It was merely a time constraint. We had a lot of features that we needed to implement, so both in hardware and software. It's definitely possible to do it. We have enough GPIOs on the microcontroller. We have 18, so that would definitely be a possibility.
A couple questions. How often do you send out this ID?
Right now we're sending out a full ID sequence every 100 milliseconds.
Oh, wow. And you have enough battery power for a long
Yes, we have enough battery power for the duration of the race, which is 1 hour. And in fact, calculations show, although we haven't tested it with Pavel, that the lithium ion should last 80 hours.
And then one other quick question. You're measuring distance by power.
Yes.
So what happens if it's humid or if there are different weather conditions? How do you deal with that?
Well, we haven't really tested it in a wide range of temperatures. We've generally been testing in room temperature. But according to the manufacturer of inner engineering, the sensor should have equivalent power distribution from, I believe, minus 15 degrees to, I think, 115 degrees Fahrenheit. So it's a very wide distribution. At least that's what they claim according to the sheet.
What kind of accuracy do you get in terms of the distance calculation with this method?
We get, I believe we get about plus or minus half a meter.
Is that done by testing?
Yes.
What's the repeatability of the distance measurement over multiple devices? Do you do any kind of calibration?
Yes, we do initial calibration. Basically, when we first run the sensor, we have a calibration routine that's manual right now. So that's another improvement that we do to make it automatic. But in terms of across how many devices we've tested it across 3 emitters, 1 receiver. The reason we decided to do that is, again, due to time constraints. The TI already has like a battery pack, and so instead of creating our own regulator patterns, we decided to just use that and then do a beeline to the sensor.
Yeah. How easy would it be to cheat? Say to obstruct the sensor with your leg when you're drafting, or have a little device that causes problems?
One way we could fix that is because right now when you're uploading the data onto the software, we take all data collected. So if on the software, if you see that there are some irregularities with, for example, the time between ID sent and received, the race director should be able to just by himself see it and then decide whether there's maybe you don't see the signal for an extended period of time. There might be something wrong, so they'll need to. It's just we collect all the data, and it's up to the race director to identify whether there's suspicious cheating or so on.
Did you consider different microcontroller, or you just stepped with the first that was came to you?
No, we did consider a wide range of devices. We considered FPGAs, we considered DSPs.
No, I mean the microcontroller.
Oh, microcontroller. Yeah, the two main microcontrollers that we considered was a Freescale ASCII-12 and the MSP430. And we ended up deciding on the MSP430 because of the size mainly, and also because it came in a very useful package. Also, the programmers that we used were very handy because they're USB compatible. So.
I'm trying to understand the database. Does it include both the person who drafted and also who they drafted against?
Sometimes ideal.
So both IDs are in the